A robot picks up a rubber duck it has never touched, a crumpled bag it has never seen, and a weird-shaped toy it definitely was not programmed for. And it does all three without missing. Most people assume robots are pre-programmed for every single object they handle. That used to be true, but it created a real problem. The world has an almost infinite number of shapes, sizes, and textures. So researchers started asking a different question. Instead of teaching a robot about specific objects, what if you taught it to understand geometry itself? The first tool that makes this possible is a depth camera. Unlike a regular camera that only captures color, a depth camera measures how far away every point in a scene is. The result is something called a point cloud, basically a floating map of dots that describes the shape of whatever the camera is looking at. From that point cloud, the robot can figure out the surface geometry of an object it has never seen before. It does not need to know the object is a mug. It just needs to understand that there is a curved surface here, a flat bottom there, and an empty space in the middle. Now the robot has a shape. But knowing a shape and knowing how to grab it are two very different things. This is where grasp pose prediction comes in. A grasp pose is just a position and angle for the robot's hand. Where to place the fingers, which direction to approach from, and how wide to open the gripper. Researchers train models to look at a point cloud and output a list of candidate grasp poses, ranked by how likely each one is to actually work. To train those models, researchers use simulation. They build virtual environments where a robot arm can attempt millions of grasps on thousands of different virtual objects. Every success and every failure gets recorded as training data. The key insight is that a grasp that works on a cylinder in simulation probably works on a real water bottle, a marker, or a rolled-up sock, because the geometry is similar. The model learns to transfer that knowledge across shapes it has never physically encountered. Some newer approaches go further by using neural networks that process point clouds directly. These networks learn features like local curvature, edge sharpness, and surface flatness, and they use those features to score potential grasps without needing handcrafted rules. There is also a technique called analytic grasping, where the robot uses physics equations to reason about whether a grip will be stable before it even tries. Think of it as the robot doing a quick mental check. If I squeeze here, will the object slip? Real-world grasping is still messier than simulation. Objects are shiny. They are partially hidden. They wobble. Researchers are actively working on closing that gap, and it is genuinely an open problem. But the progress has been real. Robots in research labs can now pick up objects they have never seen at a success rate that would have seemed impossible just a few years ago, not because they memorized every shape, but because they learned to read geometry. If you want to go deeper, look up the terms GraspNet or 6D grasping. There is a lot of interesting work happening right now that is worth poking around in.